So we're going to start this problem by adding force 1 and force 3 here. Because we already know the magnitude and the directions of these two forces, why not just add them all up? We'll add these two together, and then we'll do the hard part of adding F1. So here's my F3 vector. And the length, the magnitude of this vector is 260. And the direction of it is given by one of those reference triangles, 12, 5, and 13. So let me just figure out the angle of this vector. I recognize that these two angles, here and here, are the exact same. So looking at the angle of my reference triangle, I can figure that out because I know the sides of the reference triangle. I can set up a tangent statement. The tangent, that angle, will equal the opposite 5 over the adjacent 12. That angle will equal 22.6 degrees. Alright, so I got the magnitude and the direction of F3. So now let me draw in F2, and I'll draw that in purple. So here is F2, and notice that I made it shorter, noticeably shorter than F3. You want to make your picture as accurate as possible. These forces are the lengths, are the magnitudes of these vectors. And I also recommend at every junction where you do that head to tail thing, draw in an X and Y axis. That really helps you figure out the angles and the geometry. Alright, so our resultant here, the resultant of force 3 and force 2, that's just drawn from the very beginning to the very end of this whole structure. So I'll call this force resultant of 2 and 3, because this is the sum of force 3 and force 2. And we have no idea what the magnitude is, the length. I notice that I have a side and a side, and if I only knew this angle here, I could figure out this side by using law of cosines. So let's see if we can figure out this angle right here. So I have to work the geometry a bit. This angle right here is 22.6. This one here will also be 22.6. It's one of those geometry principles. There's a name for it, but I forgot it a long time ago. And this angle right here, well, that's just 90. That's just between the positive y-axis and our 200 vector. So altogether, 90 and this 22.6, we can add that together to get 112.6. And now we have our law of cosine set up. So we can write that out. And we can crunch the length, the magnitude of force resultant of 2, 3. And we'll get that it is approximately 384.1 newtons. Alright, so now that we've added up force 2 and force 3 together, now we can add this result to F1. But before I do that, I really need to figure out some direction for a vector here. So, I can use the law of sines to figure out this angle. So let me set up a law of sine statement. Alright, so I'm using the sine of this angle over its opposite side equals the sine of this angle over its opposite side. And of course I can do the algebra, crunch the math, and I'll get that the angle is going to equal 28.7 degrees. Now we have to be careful here. This isn't quite the direction of this vector here. I really need an angle from this vector to the x-axis or from this vector to the y-axis. So what I'm going to do is I'm going to take that 28.7 we just found and add it to this 22.6 to make this complete angle right here from our vector to the negative y-axis. So if I add the 22.6, I'll get 51.3. Alright, so now we have the magnitude and the direction of this vector. And now we can move on to adding force 1. So now I'll continue off of force resultant 2, 3, and I'll draw F1 so I can add it. And note that this angle here is 30 degrees. And I have no idea how long this vector is. And I always want to draw a y and an x-axis right here because that always helps. Alright, so here comes the good part. The whole point of this exercise. So, as I've drawn it here, my resultant will be this one right here. But of course we don't know the length, we don't know the magnitude of force F1. It could be here, it could be very long, or it could even be in the other direction. So for the first case, this would be my resultant. This would be my resultant here, this would be my resultant here, and here. So we want to choose the option that makes the length of this complete resultant as small as possible. So it's obviously not going to be this one. That's pretty long, and it gets shorter, but it's still long, and this gets a little bit shorter, and it actually even gets longer as you go out this way. So it turns out the one that will make it the shortest is if you draw it at a complete 90-degree angle with the direction of F1. So if you imagine a point here and just some dotted line, what's the shortest distance between this point and the dotted line? Well, just imagine all the possibilities. And the one that wins out is the one that's 90 degrees. It's going to be none of the other ones. Same exact thing here. So I'll remove all the other pictures and just keep the one in which the resultant, the red line, is 90 degrees to the yellow force F1. Alright, here's that 90-degree angle. We can determine some of our angles here straight from the problem description. This guy right here is 30 degrees. And because this one right here is 51.3, we know this one right here is 51.3 as well. So now actually I have a right triangle, which is super easy to work with. I don't even need law of sines, law of cosines. To determine angles, to determine sides, I can just use sine, cosine, and tangent in Pythagorean theorem. Remember, those things only work with right triangles, but here we have a right triangle. So if I want to choose to focus on this angle right here, that 51.3 plus that 30, that's going to be 81.3. This side right here is the opposite of that 81.3, so I can write a simple sine statement for that. The sine of that 81.3 degrees will equal the opposite, which is my force R magnitude, over the hypotenuse, which in this case is the 384.1. And we can easily figure out that the force resultant will equal 380. And that will be a force, a magnitude, newtons. In the same way, I can figure out what my force 1 magnitude is by just treating that as the adjacent of this 81.3 angle. So I can write a cosine statement for that. So there's that cosine statement. And I get that force 1, the length of it, the magnitude of it, will equal about 58 newtons. And there we go. These two are the answers. This is the magnitude of the resultant force, and this is the magnitude of F1. Alright, I hope that made sense. If it didn't make sense, feel free to ask questions in the comments.